Hi, everyone. Thanks for joining this webinar on natural language search. My name is Praful. I work with this company called Coseer. Before we dive into NLS, let me just talk a bit about Coseer for maybe 30 seconds. We are a cognitive automation company. What we do is use AI that has been written specifically for natural language to automate complex workflows at enterprises. Workflows that we are very good at involve steps like finding an answer, so the whole aspect of natural language search, which we'll talk about, but also just reading through a bunch of documents and structured data and returning with some synthesized insights. At a basic level, we are also very good at extracting structured knowledge out of unstructured information that you may have, or either in your internal repositories or the web in general, or redaction. Now, this is a use case that is getting very popular with the government bodies and regulatory teams at various organizations, where we can identify personal or classified information and then process the document accordingly. Today, we are going to focus on natural language search. And the whole concept is it's the search across your information, whatever you call knowledge. It's a search across that knowledge as if a human understood everything and understood your question and answered to you what you really need. So let me show you a very quick demonstration. What we've done over here is essentially taken some consulting documents that we could find on the web in general. Now, you can imagine that we cannot share any of our client information. It's very sensitive. But we took about 70 or 80 consulting documents just to put this together. And let's say you somehow want to know about cuts in USPS manpower, and you ask your associate to find that answer for you. Now, what they would get back with is not just some documents, but actually something like what you see on the screen, the exact chart of what you are looking for. By the way, this document does not even have the word manpower. So your associate could figure out that by manpower, what you really mean is the workforce, and got you this answer. Now, that's, of course, a very standard English translation. But if you were working in finance or healthcare or some other specific sector, these kind of associations can be automatically figured out by an associate. What our natural language search algorithms do is exactly that. The three problems we have been able to solve using our artificial intelligence. So first is this problem that when humans say something, that is not exactly what they mean. So for example, there's a keyword. It's very likely that the keyword means keyword itself, but there's so many other things it could mean. It could mean a synonym, it could mean a hypernym, a troponym, it could mean something that is very context specific. So let's say the keyword is good day, the phrase good day. It means certain kind of solar insolation, it means certain kind of temperature and wind chill factor in San Francisco. But if you are in Antarctica and you say this good day, and if you use the same parameters, that cannot be a good day, because that probably means end of the world. So you see, the simple concept of good day is just so different as per the context in which it is there, right? It could mean so many different things. Sometimes it's a satire. So when you tell someone a good day, you really don't mean that as a good day. You actually mean the reverse, etc. We figured out that any AI algorithm based on structured input, like a deep learning is, or a random forest, or all these machine learning techniques that we talk about, or Watson and TensorFlow kind of tools that are based on those kind of techniques. The main problem is that those tools are meant for structured data, while the human interaction is completely probabilistic and unstructured. And that is when we went out and created a completely different algorithm. I don't want to go into the technical details at this stage. Suffice it to say that this is an algorithm that is meant to handle that complexity, and hence we are seeing such great results. The second problem, which is related to that, which we were to solve, is that if you, let's say, decide somehow to use the traditional algorithm like deep learning, there's two problems. One is that it needs a lot of data to train. Now, if you're a Netflix and you have a clickstream data, then that's not a problem at all because it's all in tables. It's very easy to reconfigure it and train a deep learning model based on that. But if you're in a natural language domain, you may not have all that data available. Plus, you need to annotate that data before it can get into any deep learning algorithm. And that is a problem we have been able to solve. Our training starts with the base corpus itself, and it could be large, it could be small, and it keeps changing. And in most of our situations, the corpus, there's additions, deletions, the version control things. But you can also take secondary contextual corpuses to do that. I'll just give you a quick example. When we did a project for a tax consulting in UK, we had to ingest hmrc.com, law.com, investopedia.com, just as secondary corpuses where they had these glossaries or even otherwise just a text that the machine read to form its opinion about the context specifically. And of course, there's always continuous learning by user behavior. If, let's say, you ask a question and click on the third answer to that question, that is learning for us. And there's human overrides and other such things possible, which nowhere in this entire learning process is there any need for human annotated training data. This step, without using our algorithm, becomes prohibitively expensive. And a lot of times we have seen our clients just step back from using any kind of a system, any AI system because of this step. And that's the second problem we've been able to solve. And the third problem we solved with our endless workflows is that search per se is not a problem people are trying to manage. Search is a step of a wider workflow. So most of the time, people think that there's a document repository where all the documents, which are the searchable documents or knowledge documents, are put, and then there's a cognitive system to manage that, and you can use a natural language search. But actually, things can get much more complicated. So, for example, you may not even be looking for the particular documents. You may be looking for something else. So, if you go back to our little demo, and let's say we start a new one. Let's say we just type in natural resource, and it has come back with 41 documents. What it is telling you here is that, hey, I have too many documents. Would you want to enter some more information? Let's say we are not worried about that right now. So we get all this information, but as I was saying, all these documents or snippets that are coming across from the search, we may not be interested in those. We may only be interested in the experts. And as you can see here, the natural language search now is just a contributor to the overall workflow where you just want to pick up the phone and talk to some people. So that's part of the workflow that you're trying to solve. You're trying to connect people here, not necessarily solve the search problem. The other thing is that why do we need to have custom made knowledge documents for any kind of a search implementation? Why not just take all the client ready documents and just redact them for security and compliance and other such things, and make sure that everything is searchable almost immediately? Why do we wait for creation of a document over there? And you can just extend this concept even further. You can say, knowledge is not only what you have in your own repositories. Knowledge is whatever is related to your topic of interest. So why not just take the web data and also put that in? To that extent, I'll show you another quick demo. This is something we developed for one of the financial brokerages, where the knowledge is everything on the web and social media. So, for example, if you can see my screen, what it says is that for over the last week, it has downloaded 3,200 different documents for Apple, of which about 12 or 15 bullet points are worth studying. Everything else is just kind of redundant or irrelevant. Now, and again, synthesis is a slightly different capability than natural language search, but you can imagine it's kind of tied at the hip. And joining them together, you can come to such powerful workflows that solve a bigger problem rather than just search on its own. An extension to that is the problem of what kind of data types are you going to search for. So, people typically think of natural language search as just a tool to search documents, but we have been able to implement it for text, of course, and tables and images, and chemical structures and data lake queries. The point that we're trying to make, the problem that we solved, is that search itself is just a component of the workflow that matters to you. And we have developed the whole search algorithm in a way that can be really molded towards your workflow and get to a very high accuracy. Some of the examples of our work are, for example, as I just showed in the previous page, for a pharma major, we are using that concept, that console, to essentially collect all the information they already have about a molecule, which then accelerates the preparation of documents for the Federal Drug Administration. For a tech major, again, we are doing this analyst-based customer support, where their customers come in and they type in their query. If they don't find the answer right away, they would otherwise create a ticket. And using NLS, we have taken this case deflection rate from 10% to a much higher number. So for a financial conglomerate, we have implemented the IT help desk, kind of a chatbot for their internal thing. This is integrated with Slack and their own internal chatbot, and we kind of manage through APIs. And this is a very interesting use case for an oil and gas major. What we've been doing is essentially creating briefing packets for topics that show up in calendar. So let's say you are an executive and suddenly a meeting shows up in a calendar about a topic, let's say cognitive computing, and you know nothing about cognitive computing. What our system will do is integrate with your calendar, figure out that there's a meeting coming up for cognitive computing in the future, and then create a meeting packet, or I'm sorry, a briefing packet for that particular topic, cognitive computing in this case, and send that to you in your inbox. So you don't have to worry about that you're walking into a meeting unprepared. Everything is in your inbox. All you have to do is to open it up. So I'm just trying to give you a flavor of the various kinds of implementations or the workflows or the knowledge management that is possible just using a simple concept of natural language search. This chart is available. I'm not going to go through this. This chart essentially compares Coseer's natural language search to other technologies that people usually consider. On the page from which you logged on, you should be able to download this presentation and this chart separately, as well as there's a white paper which kind of covers most of the things we talked about. So that's the end of my presentation. Essentially, we are talking about a system that returns actionable answer as if a human understood the whole corpus and your query to find it. This is all done without any human annotated data, which is usually a big bottleneck in implementing AI systems. And it essentially configures to very specific workflows. And the idea is to solve your workflow, not to demonstrate any technical prowess or anything. So with that, I will end my prepared remarks. I can already see a lot of questions popping up in the text box. In case I don't get to you, feel free to email me, and I'm happy to set up more time. Or in case you want to get a deeper demo or a more deeper discussion on technology, we can set that up also. Thank you so much for your time today. I look forward to chatting more.